First thing, all right, just to tell you what you're going to do. Basically what you're doing is, for the first part here, the inequalities in the triangle, is you're going to be given something like, here's a triangle, they'll give you all the side lengths, and they'll say, based on the side lengths, decide which angle is the biggest, decide which angle is the smallest, put them in order, that kind of thing. Or they're going to give you a triangle and all the angles are given to you, and they're going to say, look, based on the angle measures, decide which side is the biggest, which side is the smallest, that kind of thing. All right? It's not necessarily a very difficult concept to grasp, and it's not really, the problems, guys, aren't necessarily going to take that much time. The whole idea is, if you know where the longest side of the triangle is, that angle that's directly opposite it is always going to be the biggest angle. So if I've got the longest side here, so I would give you a number value here. All right, I would give you all three. You would be, like, that's the biggest side, you use the biggest number. That one that's directly opposite it, again, just kind of drawing an arrow, because we talked about the angles opposite sides before. You just draw an arrow to the side opposite it, or the angle opposite it, and it's always going to be the biggest number. All right, likewise, if I knew that the side was the shortest side, if I were to draw an arrow back to the angle opposite it, that would obviously be the smallest angle. So it's basically biggest matches up with biggest, smallest matches up with smallest. And when the problems are going to say something like, list the sides in order from biggest to smallest, or list the angles in order from biggest to smallest. And in the problem, if I give you the angle measures, that means you need to list these sides in order. Like if I give you the angle measures, I'm not going to say list the angles in order from small to big, because that's just basically you go and here's the biggest number, so no thought to that. That's like elementary school stuff. Okay, so it's always going to be directly opposite of whatever is given. If I give you the sides, I'm going to ask you to do the angles in order. If I give you the angles to the side. But guys, it's just a matter of you making sure you go shortest side to smallest angle. Kind of tracing arrows in there. You can either do it like, because your work will be in the workbook, so you can either draw them in there or just mentally do it. You know, it doesn't matter. Okay, as long as you can match them up correctly. Now, the biggest mistake people make is, my examples are going to be this way. Okay, it doesn't mean every single problem I give you is going to say list it from smallest to biggest. Sometimes it'll be biggest to smallest, it'll be reverse order. Or sometimes it'll just say what's the biggest angle or something like that. All right. So make sure when you're doing problems like this, if you know it's going to say list something in order, you know, make sure you're reading the order it needs to go in. Don't make a common mistake like that. All right. Now, one thing you have to make sure you have first is all the angles in the triangle. All right. They don't have numerical values in all of them. All right, in this case, and probably on most of them, ones especially that I will give you test-wise, guys, you will not have all of them there. You're going to have to add the extra angle. So first step would obviously be make sure you have a number on every angle, just to verify and make sure that you see which number is the biggest and which one is the smallest. All right, so first thing I would do here is find the measure of angle O. What would be the measure of that angle? Or what should I do to find the measure of that angle? Yeah, so I would add the 62 and 58 and subtract it from the 180. 60. So what? 60? Okay. All right, so that would be the first step. Now the whole idea there was just to make sure that that's the biggest number, that's the smallest number, and this is the middle. Okay, so if I'm asking you now to go ahead and list the sides in order from smallest to biggest, I would go to the smallest angle first, which is N, correct? Draw a little arrow from it, to the side opposite. That means that this side right here is directly opposite that angle. So that means that MO is the smallest side. This is the middle angle, correct? So, side opposite that angle will be MN. That's the middle side. That's the biggest angle. Side opposite ON biggest. Is everyone okay with when I say the side opposite, what I'm kind of doing there? Yeah. All right. Like I said, most of the case where people mess up is they just don't read this part. Like if I flip it on you, someone will still do it smallest to biggest, even though I want it in reverse order. Make sure you're reading the directions. Now, this problem right here, where there's two triangles, always work with it in order that they say. I'm doing smallest to biggest, so the way I'm going to work with this is I'm going to deal with the smallest triangle first and go to the biggest. Yeah.
Wait, didn't you just do on that one? Didn't you just go biggest to small?
Did I?
Yeah, MONNON.
No. That's small. 58 is a small triangle. So MO is opposite 58, so it's a small triangle. All right, so on this one here, basically what I'm going to do, okay, is I'm going to work with the smallest triangle first. So triangle MLK. All right, so again, I've only got two of the angles given to you, so that means the first thing you do is get this angle in. So it's 45. Okay. All right, so then I would go in and I would go, okay, this is my smallest angle, correct? All right, so that side is opposited, so I know MK is the smallest side, right? Because it's opposite the smallest angle. And I know it's the smallest side overall because it's the smallest angle in the smallest triangle I'm dealing with there, so it has to be the smallest side. All right, next up would be the middle side. Well, 45 is the middle angle. So what side is opposite this 45 degree angle? KL is next. All right, and then the biggest side in this triangle over here is which one? And this triangle here is LM. All right, now, for this problem to actually work out, okay, that LM has to be the smallest side in the other triangle that I haven't listed yet. If that's not the case, okay, then you'd have to rearrange some sides and things like that. But the problems they give you, this one should always be the largest in one triangle and also the smallest in the other one. So LM is the biggest side in my triangle on the left-hand side, but it's also the smallest over here. And I know it's the smallest because that 30 is going to be the smallest angle. Okay, like if I found the other angle would be 55. So I know 30 is already smaller than 55, so that side is opposite the 30 degree angle, so I know it's the smallest of this triangle. Now, here's the thing, don't list it twice. It's only up there once. Okay, I'm not going to list it like LM and then LM again because it's the same thing. This just kind of links the two triangles together. All right, so I know I'm at the smallest of the big triangle. Now I'm going to move to the middle side of the bigger triangle. So that's my middle angle. That line right there is the one that's the middle side. So my next one is LN. And then the only one I didn't list yet is which one? MN. All right, so this would be smallest to largest.
Even though it's the largest angle on the bigger triangle, if that one's at 100 and the other one's at 95, then I don't know.
The reason I put it where I know what you're saying because that's a bigger angle.
I mean, I know I can see it's bigger, but
just deals with the fact that you understand that this triangle was a whole lot smaller than this one. So all the sides are probably going to be smaller than that. The reason I would definitely know it's bigger is because this side right here is the smallest of this one and the biggest there. So like for it to be the smallest in this triangle, I know that every other value has to be bigger than this, which automatically, like everything beyond, like everything prior to it has to be smaller. But this will always, the way this will always work for you guys is this one right here is always going to be biggest for this one, smallest for that one. So it's always going to act as a, like you're not going to have to rearrange anything. You just kind of deal with it as you look for the smallest triangle, this goes first. next side of the triangle for this side, so on. So if they did like 3 triangles, like the next one, if I did 3, I mean the next one, I would have to make it like a huge triangle, just so you know, you would understand that that's a way bigger triangle than this one, that's a bigger one than that. So you're always working with them, the triangles in the same order that it's in right there. All right. Okay, now, the next thing. All right, it's going to be this one, okay? This triangle inequality here. This thing, like I said, this is going to be one thing that gets used in chapters beyond this. And it will be referenced in the other chapters as the triangle inequality. Okay, basically all it says, like all the stuff that's up there, is that for a triangle to actually exist, if you add 2 side lengths together, that sum has to be bigger than the third side. Okay? If you ever have 2 sides that add up, and they are less than the third side, that triangle technically is not existing. There's absolutely no way you can draw a triangle that fits the numbers that would be there. Okay? So there's a few different problems that are going to stem off of this. The most basic one would be, I'll give you 3 numbers, and I'll simply ask, would it be possible for me to draw a triangle that had the side lengths that were these 3 numbers? Like I would give you 3 numbers like 3, 6, and 8 or something like that. And I'd say, would it be possible for me to draw a triangle with side lengths 3, 6, and 8? And you would have to go back and kind of use this theorem, right, to test that. Now, the theorem lists out all of the 3 combinations of adding the sides together. Okay, so there's technically 3 inequalities that are happening. All right, it's just but when I actually do the problem and you test whether or not you can actually make a triangle using side lengths, you're only going to have to do one of those inequalities. All right. So, can I go past this yet? No. Right back. Okay, you good? Is anyone else give me a seat? All right. I'll worry about that later. Okay, so for this type of problem, like I say, you're not going to have to do all 3 inequalities that were up there in that theorem. The only thing you're going to have to worry about is taking the 2 smallest sides, the 2 smallest numbers that are up there, so I don't know if they're sides yet, add them together. Okay? For this to actually be a triangle or have a possibility of becoming a triangle, those 2 sides have to add together and be bigger than the third side. So if I was testing this, like on the first one, I would do my 2 smallest numbers are these 2, correct? Right? So I would do 8 plus 10. And then I would check and see, is that bigger than 12? Yeah. What is it? All right, so I would say, look, I know 18 is greater than 12. Yes, that can represent the side length of the triangle. It is possible for me to draw a triangle that exists that has side lengths 12 centimeters, 10 centimeters, and 8 centimeters. If it's anything other than this, your answer is no. All right, so if I go down to the next one, what 2 numbers am I going to add together there? 7. So I would do 7 plus 7. And see, is that greater than 14? 14 is not greater than 14, so my answer is no. All right? This would be, you could almost draw a triangle that fits that. Almost. Very close. Okay, like you took a ruler and all that stuff and actually measured out like 7, 7, 14 if you can. This one here, what 2 numbers am I going to add together? 18 is 1. 18 is 1. So again, I would check and make sure it's bigger than the third side. Is it? No. So the only possibility is if it actually is greater than, guys. I'm telling you, anything other than that, there's no answer. The biggest mistake is people who put yes for the number 2 one. You'll say, oh, it's equal, but that doesn't fit the inequality theorem. Okay, because the theorem is saying that when you add them up, they have to be bigger than that third side. Now we only check those because if I did like 10 plus 12, if I included the bigger side, obviously the sum was going to be bigger than that third side that's left over. Okay, so there's not a need to go through the other two inequalities because both of those would include the largest number. Okay, now the other problem that you guys will be doing with this, or the other type, would be one like this. Right? So it's the same kind of idea that I just had up there. The only difference is here, I'm only giving two numbers. So I don't know if 3 is the largest number, the middle number, or I don't know if 2 is the smallest number or the middle number. I have to actually write out multiple inequalities for this one. All right, so all I really know, like if I drew this triangle out, X, Y, Z. So all I know is I know that side's 3, I know that side's 2, and this side is whatever you want to put there. Like what letter? I need a letter. Okay? Sure. Okay. Good. Everything. All right? So I don't know what it is, but basically what I'm going to do is I'm going to solve out some kind of inequality or right inequality to represent all of the values that could fit that. Okay, now, this theorem, right, the one that was up there had 3 inequalities in it. Okay? And it was basically me adding together all the possible pairs, okay, and set them greater than the third side. So if I went through and added them together, like what are two sides of that triangle up there right now? Which one? 3 and 2? So I can do 2 plus 3, and then for it to fit this theorem, that has to be greater than J. Again, I don't know what it is, but I'm just using the theorem there. What's another two sides? J plus what? 3. So if I do J plus 3, that has to be greater than 2. And then the other one I didn't do is what? J plus 2. Okay, now, here's the thing. When you start solving these out, there's one that I can just toss away. One that's not going to make any sense. The middle one. Why do you think this one doesn't make sense? Yeah, well, it's kind of bigger than it, but if I solved it out, do I get a negative number? Yeah, I can't have negative side length, so if I just say greater than -1, that also encompasses like -0.9. I can't have a negative side length. So there's going to be one that's always going to give you negative, you just kind of toss it out. Alright? But the other two will work. They will give me actual answers that make sense. Like in this one up here, 3 plus 2 is 5, correct? So I know that this value right here, alright, has to be less than 5. Okay? If I solve this one out down there, you get what? J is greater than 1. So looking at this, I know that this side right here, all the possible values would be all the values that are in between 1 and 5. Okay? You can write that out in words. You can say, look, the third side for all the possible measures for x, y are in between 1 and 5. I would probably prefer you just to write it like that. Okay, this would be a compound inequality using those two inequalities. All right, but anything that's showing me that you understand anywhere from 1 to 5, not including 1 and 5, because that would work, is okay. All right. Now here's the thing. You're not going to write these out every single time, because if you look at the way I got them, I just took these two numbers, added them together to get this one. This was 3 plus 2, and this was 3 minus 2. You always add them to get the upper boundary there. You always subtract them to get that lower one. Okay, so the upper number, the higher number, those two added together, whatever two values they give you, you subtract them to get the lower one. You can do them quick that.
I thought it was only 1 plus 2.
That's why I don't have an equal. It's saying it can be greater than 1. It can be all the way up to 1, just not including 1. Same thing with 5. It could be 5 because 3 plus 2 is 5. Yeah. The only way I would have to word the problem saying what would be the integer values that would work, because that would be 2, 3, or 4. But if it says all possible, you need to include, that includes decimals, all the fractions, and everything. So you write it as a inequality, so it's encompassing every single number as possible. So being here, she asks, can I write 2, 3, or 4? You can't just put 2, 3, 4. Okay? You have to include every single possible value in this one. Right? So these can actually be done fairly quick by just doing that part. Alright? So with these right there, just remember, add them together, get the higher ones, subtract them, get the lower. Alright? Now, check them through, guys. All the ones that are up there so far will give you correct answers. Like 3 should be BAC for the order. 4 should be ZXY. 9's over there. It should be AB, AC, then BC. 15's over there. It's a yes answer. I don't think 16 is up there, but 16 was a no. And 21, the answer's over there. It's in between 15 and 35. And you know it's already up there, right? That answer's already up there.
Is 22 in here?
Yeah.
That's impressive.
But then 21 was in between 15 and 35. You just add the two up and get to 35, subtract and get to 15. And then the other one is over there on that side. It was from 2 to 14. So those are all correct. All the ones are up there. The only one up there was 16. That's your option, but you chose not to. And 16 was a no answer. So 7 plus 6 is 13. It's 2 and 14. It's right here. Yeah.
Oh, it's easy to just
Yeah. They'll give you the- All right, the last bit of this stuff, guys. Okay. Guys, this last thing, this hinge theorem, it's essentially the same as what we started with this kind of stuff, where you're doing the smallest to biggest kind of thing. The difference between the hinge theorem and then the one that was over there, like on the classwork, like number 3, 4, and 9, is now you're going to be comparing values in between two triangles. You're still doing greater than, less than, but now in this case you're going to add equal to. All right? So essentially the way it works, and I did the hinge theorem, instead of doing it with words, I got it with pictures of it. So the way the theorem works is, look, if you've got the situation occurring that's up there, such as you've got two triangles, in between those two triangles you have 2 pairs of congruent sides. Okay, and you know the angle in between those two sides, you can compare the lengths of that third side. All right? So the way this works is still the same as what it would have been with the other inequalities, where you basically just find the bigger number. Whatever side is associated with the bigger number, that's the larger side. But you have to have, for this to work, you have to have these 2 pairs of sides being congruent, like the 2 sides that are forming that angle, the included angle. Okay, so it says if all of this happens, then you can make that conclusion, that this side right here with the larger angle is bigger than the side over here with the smaller angle. So the idea that the fact that, the bigger angle goes with the bigger side isn't changing. So if all of this happens, then you can make that conclusion. That's how the theorem works. All right, and there's also going to be a converse to this, but the converse is basically the same kind of idea. Just the fact that when they do the converse, or if the directions even say converse of the hinge theorem, Instead of giving you the angle measures, they'll give you numbers here on the side. Okay? Such as, can we go past it? Alright? Such as, in this case, you still have, this is the converse, so reverse order. Here you have still two pairs of congruent sides. And in this case, they give you the measure of the third side. If they give you that, then they're going to be asking you to compare the measures of those angles. So compare them. You're not going to be able to actually tell what the measure is. All you're going to be able to do is say if it's bigger, smaller, or equal. So you'd be comparing angle A to angle B. If I ask you to compare that angle A and angle B, which angle do you think is going to be the bigger angle? A. It's with the larger side. All right, and that's pretty much it. So the idea of bigger and smaller hasn't changed. All right, it's just the fact that when they reference anything called the hinge theorem, it's going to be in between two triangles as opposed to just looking at one triangle. Okay? Got it. Sure? Let's see. You got it. Tell me what it's still is. Right? And these will be how they go. They'll give you the triangles and they'll say, look, and fill it in with less than, greater than, or equal to. And look, for you to technically have this work, you have to make sure you have two pairs of congruent sides first. If I look through all of them, they all do. Like there's two pairs there, right? Two pairs there, two there. There's two there, right? Because the reflexive, the same thing here. There's one pair, there's the other pair. So they all have to have that first, which they do, right? I would hope they're not, because you're practicing doing this, I would hope they don't try and trick you with anything like that first. Okay? So going through this first one. That's equal to, you think this is what?
Less than.
Like that?
Yeah.
I agree. This one is that?
Hold on, Chris. Slow down.
That?
No, it's over there.
The other way? Yeah, less than, because that 9 goes with the angle 1, and 9 is smaller than 11, so 1 has to be smaller. What about right here? That's greater than, right? Because the 1 is opposite the bigger number, so 1 has to be the bigger angle. What about here? That's greater than. 65 is the bigger number, so 80 is opposite the bigger number. And then right here, it's greater than. Greater. Again, there's angle 1, that's opposite 4, which is the larger number. Still just a matter of figuring out which one's opposite the bigger number, just like you would do if it was a triangle by two. Okay? So these aren't too difficult, right? I hope not. All right. Okay, this would be the only other type of problem you see with these. Okay, so now in this case here, I'm still doing the same thing I did on the screen previous to this. I'm still filling in whether or not something's bigger than or less than or equal to, that kind of thing with it. And I know I'm going to be able to use that hinge theorem for this because I've got two pairs of congruent sides here. Okay? Now, since 5 and 6 are two different numbers, I know that those angles are not going to be equal to each other. But I can make a determination between that angle and that one as to which one is going to be the larger angle. Okay? Which angle, out of the 2x minus 12 right here, and this 36 right here, which one is directly opposite the larger number? 36. So I know that at 36 has to be the larger value. Whenever the question is asking range of possible values, they're saying set up an inequality. Not an equality, not something with an equal sign. Okay? Do you solve this the same way you solve a regular equation?
No.
Yeah, so I would do 2x is less than, how much?
48.
48. You divide by 2 and get x is less than
24.
24. Now, would I probably stop right there? No, I need to plug it in. Now, but think about this for a second. Oh, I got right. If I just say x is less than 24, it counts for negative values also, correct?
No.
Right? Like negative 3 is less than 24, right? Negative 20 is less than 24, right? If I plug negative 20 into there, that wouldn't make much sense. So in order for this to actually work, I need to try and find the smallest possible value that angle could be. So I do actually have to create a range here, just because we want side. What's the smallest angle that we work with?
1.
1. So we never did 0, right? So I don't have any angle measures that equal 0. So what I'm going to do is I'm going to set this equal to 0. All right, because I want to know what value of x is going to make that 0. I can't have it be 0. It can be close because I can do extremely small decimals. All right? So if I solve this out, I'll get 2x 12, x equals 6. Okay, and what this does, this tells me the value, the smallest one I'm going to start with. This gives you the other side. This gives you that side. Okay? This comes from the hinge theorem. This part right here just comes from, you should have a knowledge of the fact that I can't have an angle measure that's 0. So I have to have a lower boundary on it that would create a 0 angle. Okay, and I have to have a value that's greater than that to actually make a positive angle. Something that would. Okay? Alright. So this would be the complete answer. This would be a good chunk of the answer. So if you got that part down at least, that'd be pretty good. Alright? It'd be great if you got the entire thing done. Okay? So this is applying the theorem. This is just adding that fact that you understand that I can't have a negative angle or something less than 0. Right? So